So, folks were asking earlier about quizzes this week. If you looked at your calendar, your upcoming Schoology events, the only thing really this week as far as assessments go is this Friday. We have our DMR 6, which is this. That's it for this week. We'll have a concept quiz next week. I think this week, either tomorrow or maybe Friday, is an absolutely fantastic opportunity for those that need to do retries on their concept quiz 5 or 6 to do those. Yes? A fantastic week. You really should be doing that. Remember last time when we got up to the unit test and how like that last week was full of like a touch of panic for some people? Like, oh my gosh, I need to do retries. You know what I'm talking about? Why don't we do that now? So that when we're leading up to the Unit 2 test later on, less panic for you. Same amount of work for me. It really doesn't make too much difference. I'm going to do it one way or the other. But if you're not panicking at the last second, I think that's always good. So consider tomorrow, consider Friday for a concept quiz retry on either 5 or 6. Right? Oh, sorry, that last one's in a bad spot. We can talk about that one. So first one should be 4/5. The second one should be 8x squared minus 19x plus 31. Third one should be x equals -3. And then got a domain, a range. Yes, it's a function. We can talk about the reason. So you've had a few minutes to look things over. Do you have any questions? Great.
For number 3, I got -x equals 3, not -3.
Oh, sure. So I would say, if that's the case, I would say you're not wrong. You're just not done. So if let's see here. You know what? Let me try to jump off where you're at. So if you had that, I am guessing you probably got here, but then instead of subtracting 5x, did you subtract 6x from both sides? Okay, so if you do this is perfectly good. You end up with 5x minus 6x is -x plus 4 equals 7. All right, so then you probably subtracted 4 from both sides, and you got here and you said -x equals 3. So I would say then, remember the goal is to solve for x, and we've talked about in the past how solve for x really means get the x by itself or isolate the x. I would say at this point where you have -x equals 3, the x is not really by itself yet.
Right.
So when it says solve for x, it really means solve for positive x.
Divide by negative?
Divide by -1. Yeah. Have you ever seen it like this? Maybe some of you have seen this. Do you guys realize that -x is really the same as -1 times x? It's really the same thing, right? So if I wanted to get rid of a -1 times x, I would divide by -1, and that's where we came up with our x equals -3.
Right.
So like I said, I don't think you were wrong. You just weren't done yet. Yeah. Okay. Thanks for asking. What else can I do to help you guys? So I have a question for you. Is this starting to feel like something where you're going to make a 4 out of 4 on Friday? I sure hope so. I think you can do it. I'm really pulling for you. I hope that when I grade it, it's just going to be a bunch of 4s. I guess maybe an occasional 3, but it would be awesome if it's just all 4s, right? That'd be super cool. So what we'll do on Friday, do you guys know we have kind of a funky schedule coming up over the next 2 days?
Yeah.
Got the college fair thing coming up tomorrow afternoon. And so our schedule on Friday, us in particular, is a little bit weird. We're going to have kind of an extra long class on Friday morning because we're not going to meet on Thursday. So they're bumping that to Friday and combining it with what we normally would have done on Friday. So we're actually meeting first thing in the morning on Friday instead of at the very end of the day. Yes? Have you seen this? Yeah. So it's a little bit weird. You're going to want to check out the modified schedule for sure if you haven't already done that. So we'll meet. I won't see you tomorrow. We'll meet on Friday. So we'll warm up this again on Friday, and then probably at the end of the class, we'll do the actual DMR quiz on Friday morning. Sir?
Don't we have like 75 minutes of class?
Yeah, so it's kind of like two classes, right? So they're saying, hey, you didn't get to meet on Thursday, and you're supposed to meet on Friday, so let's just take those two classes and make one big class. So we'll try to get a lot of variety of things done. We'll still be doing like graphing lines or linear equations. We'll do a variety of activities. We're going to just kind of have to scrunch some things, and we'll combine and cut and do stuff. So, yeah. Okay, so I've talked enough about that. Do you have any questions about this? Last chance? Fantastic. Okay, so let's move forward. We're going to do a little bit more work with graphing of lines. And if this will cooperate, we'll get there. There we go. Okay, you know what? I want to do this. Let's go back in time a little bit. Yes, I want to go back in time. So instead of this is what we just did. So instead of moving forward, will you guys flip backwards one page? I just want to review and make sure you know how to do these. So just go back to that number 2. It's just on the previous page. This is one that we did not do. This is in practice 2. So I just want to review this a little bit, and we're just going to move forward into some other graphing of lines today, but I thought it'd be good to go back and try one. Okay? So notice the instructions here say solve for y. So that's step number 1. Please solve for y. And then once you've solved for y, hopefully you can identify the y-intercept and the slope. And once you've identified those, maybe, just maybe, we could get a good graph of this up on the x and the y axes. So please give this a try. This is really similar to the one we finished with last time. Let's look at this and make sure we're on the same page with solving for y. So let me just get some ideas from you guys as well. Sometimes people get confused and they try to solve for x. That's something we might do, but this one says solve for y. So if I'm going to solve for y, any suggestions on what I could do to start that process in the best possible way? Noah, what do you think?
Plus 3x.
Yeah, we need to add that to both sides, right?
Yeah.
Yep. So I'm going to go plus 3x, and this is a time when sometimes people will be a little uncomfortable with this because they will look at the right side and they will say, wait a minute, you cannot add 6 plus 3x, right? Can you? Why not? Why can't you add them and combine them? They're not like terms. You know what? We don't stress about that. It's true. They're not like terms. And so in the end, I'm going to get 4y. Oops. I'm going to get 4y equals, what is 6 plus 3x? It's just 6 plus 3x. So we don't get too worried about trying to combine those. We're just going to leave it as it actually is. So we add 3x to both sides. That would be step number 1. I'm trying to get the y by itself. You can obviously see it's not. It's got that 4 right there. Caroline, what would you do to try to get the 4 away from the y?
Divide by 4.
That's right. The way I like to show this for this situation is I'm going to divide by 4 here, and then I'm going to divide by 4 on both terms on the right side. This is going to set me up for success when it comes to getting to my slope-intercept form. And so all I have to do is just do a little simplifying, and I'll be there. So y, oops, come on, computer. Y equals 6 over 4. What's 6 over 4? Did you guys do 1.5 or did you do 3 over 2? 3 over 2, okay, that's fine. Plus 3/4 x. Okay, so that would be a good slope-intercept form. The y is solved. It's by itself. Don't lose your x there for sure. The x went somewhere. There we go. And so based on that, see if you guys can figure out what the y-intercept is. See if you can figure out what the slope is, and then try to graph from there. So I'll give you a moment or two. I know you're freaked out a little bit of the 3 over 2. It's okay. What's up?
Is this right?
Just estimate. So let's see here. 1, 2, 3, 4, 5. Yeah, that looks about right. From that point, start counting your slope off. Okay. So then as I was going around, a lot of people were asking, like, how on earth do I graph 1.5 on the y-axis, or 3 halves, right? Isn't 1.5 halfway between 1 and 2? So I'm just thinking I'm going to go in here to my graph, and I'm going to say my y-intercept is 0, 1.5. So I'm going to put it right about there. Does that seem like a pretty reasonable location? It's about halfway between 1 and 2. I promise you, I won't get the ruler out and say, Bree, I'm sorry, you were half a millimeter off, -1. I'm not going to do that, right? As long as that point is like roughly halfway between 1 and 2, we're good. If you put it between 3 and 4, we're not good. That make sense? Halfway between 1 and 2, roughly, we're good. Okay, so then I need to count off my slope. Oliver, how am I going to count off a slope of 3/4? What do I actually do when I try to use that?
Up 3, right 4.
Well said. So I'm going to go up 3, so I'm going to go up 1, 2, 3, and then right 1, 2, 3, there's 4. So I'm just kind of counting these off, estimating kind of that halfway between the vertical grid there, and getting something like that. So there's my slope of up 3, right 4, and then I'll connect those 2 points, hopefully with a nice line. We'll call that good. Arrow, arrow, all done. How you feeling? You have any questions? Okay. So we're going to keep talking about lines. So if you guys would fast forward to what we're going to do today, we'll do a couple of these and just kind of see where we land. So fast forward past the DMR that we already did, and let's get into these right here. We got 1 and 2. Okay, this is perfect. This is perfect. Okay. So can you guys do like a little comparing? Take a look at numbers 1 and 2, and how would you say that 1 and 2 are quite different from all the lines we did yesterday and the one we just did? What stands out to you, Sophia? Well, on number 2, there's an X.
There's no like other variable. There's only
Okay, what were you going to say, Mason? Same thing, okay. So in number 1, there's only, this is kind of what you were saying, right, Sophia? In number 1, there's only one variable, and it's a Y, right? And in number 2, there's only an X. And so I'm going to help you with graphing these. I'm going to try to give you a nice, happy way to remember these, okay? But I want to start off by kind of talking to you about how these actually work. So take a look at number 1 with me. And I want you to think with me here. This says graph y equals 7. So the only requirement here is that the y coordinate is 7. It doesn't give us any restriction on the x value. It doesn't say that the x has to be this. There's not even a mention of x in number 1, is there? All it says is that the y has to be 7. So I want to ask you, does this point that I'm about to draw, does this point right here fulfill that requirement?
no.
What's the y coordinate for that point?
0.
I don't think it's 0,7. I think it's more like 2,7. I'll put that up here. Remember, the only requirement for this is unique, right? There's just a y, there's no x. All it says is that the y coordinate has to be 7. Doesn't this fit that perfectly? Now, the x coordinate's 2, I get that, but it didn't tell me what the x had to be. It just said the y had to be 7. But aren't there other points that work too? How about this point over here? What are the coordinates for that point? I think it's 8,7. Yep. So again, the x, it went from a 2 to an 8. What's that all about? You know what? I don't get any instruction on the x. It just tells me that y has to be 7, and that point does it, doesn't it? The y is 7. Mason, what's up?
Would it be just 7? Like no x?
Well, so on a xy coordinate plane, you have to always have an x and a y. If I just said graph 7, I would be okay if you looked at me and said, I don't know how to do that. Because there's no way to just graph a 7. There's a way to graph 3,7 or 2,7 or negative 9,7. There's no way on a two-dimensional plane to graph just 7. Does anybody see any other points that would work for this? What do you see, Bree?
Anything on the 7 line?
What kind of? Let's be a little more specific than the 7 line. How would you describe?
0,7.
Say again?
0,7.
Okay, 0,7. That's another point that works. That's right there. That's 0,7.
I thought that didn't work.
Yeah.
Wait.
I thought that because I thought that you had to have an x.
Well, x is 0.
Okay.
Remember, 0 doesn't mean that there is no x. It means that x is 0. Sophia?
So couldn't it really be anything just as long as like your y value is 7?
Yeah. What kind of a pattern are we talking about? Like, does this point over here work?
Yes.
That's what, -4, comma 7?
Yeah.
This point over here, that one works. That one works. That one works. What pattern do you all see? What's the word? I'm looking for a word. Maybe you said it.
X-axis.
No, because the x-axis is right there. No, because the y-axis is right there. What kind of a line is that? Oh, you might have already said it. Somebody said horizontal. Isn't this a horizontal pattern?
Yeah.
So what I would do is I could connect all these points, and I could say any point along that horizontal line would fit this relationship, right? For every single point on that line, on that horizontal line, isn't y 7? Does that make sense? Okay. So here is, I'll give you a general thought here. Later on, I'll give you a cute way to think about this. If the only variable is 7, the only variable is y, the line is horizontal. If the only variable is a y, the line is going to be horizontal. That's the only way you could fulfill this relationship is with a horizontal pattern. Makes sense with all the little points up there? You guys did a good job questioning and going with that. All right, let's try the other one. Let's try number 2. So isn't number 2 sort of the opposite of number 1? Instead of the only variable being a y, the only variable is an x. So what kind of, the only requirement here is that x is -3. So I don't know, here's a point that works. Right, isn't x -3 there? That would be -3, comma 2. Can anybody see any other points that would fulfill this relationship? Sasha, what do you see? -3, comma 5 would be right there. Well, the x-coordinate's -3. That makes a lot of sense. What do you see, Julia? -3, -5. Okay, so that's down there. -3, -5. What kind of a pattern is starting to develop here?
Vertical.
Not horizontal, but vertical. There we go. So any point along this lovely vertical line, this pattern here, would fulfill a relationship up there of x equals -3. So again, just from a broader perspective, I'll write kind of a similar statement to what I did earlier. If the only variable is x, the line is vertical. Okay, so can I give you a cutesy way to remember this? Because I feel like I'm just reading faces here. I'm seeing people that are like, oh, I think this might make sense. Maybe? Question?
I have a question.
Go ahead.
On like number 1 for
Yes.
7, why do you go up 7 and not sideways 7? As in if it's a negative, you're going sideways 7 and not.
Okay. It's a great question. Let's go back up and look at that. So,
Sorry, I should have asked that earlier.
no, that's no problem. We're going to revisit both of these anyway. So you said, why couldn't we go sideways 7? So the way I read that, what I'm hearing you say is maybe over here. Okay, so there's going to be some really deep things, so I'll try to do a good job of explaining it. What is the what are the coordinates for that point? Something, comma, something. What do you think?
Something comma 7.
No, it's 7, comma 0. I remember with your coordinates, it's always x, comma y, and since this is the x-axis, this would be 7, comma 0. So valid thought, right? Because you got that 7 in there. Remember this. This is, man, if you could take one big takeaway from all this, this is a big one. I'd love for you to take this away. Please keep in mind that the graph of a line is the set of points that makes the equation true. It's the set of points that makes the equation true. So check this out. If that's going to be the case, Bray, I should be able to take this point right here. I should be able to plug it in to that equation, and it should make the equation true, right? So in our point that you suggested, what is the y coordinate? right here. What's the y coordinate?
X, comma, Y.
No, like, so I'll color code it. So the x is 7
And the Y is 0.
and the y is 0. So if I were to say what's the y coordinate, you would say 0, right? I should be able to take that and plug it in back up to the equation that we had, and it should make it true.
Oh, I get it.
So y equals 7, I would have to, I'm going to check my line here, or check my point. I would get 0 equals 7. Is that truth? Does 0 equal 7?
No. Well, yeah.
If that's the case, will you give me $0, aka $7? It's not true, is it? So since 0 doesn't equal 7, all that means, Bray, is that point you suggested is actually not on our line. So if I tried some of those other points we did earlier, we can see how they make it true. So if I tried this one right here, or any of these along this horizontal pattern, like let's say this one is 3, 7. If I tried to plug that one in, the y coordinate there is, on this green point up here, the y coordinate is?
3.
Now that's the x coordinate.
7.
So the x, it goes alphabetically, like W, X, Y, Z. The first one is x, the second one is y. And so the y coordinate's 7. So if I plug that in, wouldn't I get 7 equals 7? True. And so that means that that point is indeed on the line. If I tried any of those other ones, like this one over here is like -4, 7. If I wanted to check that one, the y coordinate is 7. So again, it'd get a little bit laborious and repetitive after a while, but you'd be able to see that all those points on that horizontal pattern, they all make the equation true. That make sense? Okay. Okay, that was a really good question. I would have never talked about that if you hadn't asked it, so thanks for asking. Is there anybody else? It's like his question started off with, well, wait, couldn't we just do this? It's a great start to a question, isn't it? So is there anybody else thinking, wait, couldn't we just do that? Or why don't we do this? Those are always good conversation starters. Okay, so let me give you an easy, I don't know, I think it's easy, a cute way at least to remember this. Let's get both of these lines back up here. So y equals 7 is up here. And x equals -3 is right about there. Okay, so I like to think about this like a ski slope. Look at the top one. If we were going to go skiing and I pointed you to a slope that looked like this one, what would you say? Boring. You're going to have to use your poles, right? Or if you're on a snowboard, you're going to have to take your snowboard off, right? So if I showed you a ski slope and I said, hey, let's go ski that, wouldn't you respond with something like that, or something like this? Why would I ski that? AKA boring, no fun, right? Why would I ski that? Do you get the connection? You see a horizontal line, why? W-H-Y or just the letter Y? Why would I ski that? Maybe that would be a hint for you to connect the horizontal nature of just the only variable being y. Why would I ski that? I don't want to. That make sense? Now can you guess the other one? If I said, hey, why don't we try to ski that, you would say? Very extreme, yes. It's vertical, it's like a cliff, right? If you tried to ski that, I like the extreme, that's pretty good.
X, no.
Oh, say again?
X, no.
Oh, like no, I don't want to? Yeah, I agree, but that's sort of like the other one. Here's what I would say. If I tried to ski that, I'd get X'd out. In other words, I probably wouldn't survive. That make sense? If I tried to ski a cliff like that, I'd get X'd out, and I don't want to get X'd out. Make sense? So just a cutesy way, if you look at that and you're like, that's stupid, I don't want to remember it that way, more power to you. You remember it the way you want to, and I'm okay with that. This is just a way that some students have been like, oh yeah, this is the why would I ski it thing, and I don't want to get X'd out thing, and that helps them remember it. If it doesn't help you, it doesn't hurt my feelings. You just remember it a way that helps you. Okay. You guys have any questions? Vertical and horizontal lines? I'll give you a second. Okay. Well, then I want to show you one final thing here before we go. That's right over here. So looking at what we just did, now take a look at this right here. Number 3. Flip over the page. How does this relate to what we just did? How is this different? How is it the same? What do you see? What do your eyes tell you? Mason, what do you see?
It's greater than.
Yeah, instead of an equal sign, we got one of those inequalities. We're going to have to deal with that. So that is a really good observation. What else do you see? Say again? A y. How would you know a y-intercept here?
3.
Okay, but how would you know that that's the y-intercept?
Because there's no x following it.
Okay, yeah, shoot. Let's go back here. Compare the ones we just did. Compare those two. Check this out. Look at those. You have those in your mind? How is number 3, other than the inequality, which Mason correctly pointed out, other than the inequality, how is this one different than those two?
There's a fraction.
Say again, Sebastian?
There's a fraction.
Okay, it's got a fraction. What else? There's something else really significant. What do you see, Julia? No? Sophia, what do you see?
We have a slope now, so now like it's gonna.
Okay, yes, there's something else. What do you see, Noah?
No equal sign.
Okay, then that's kind of what Mason pointed out. It's like it's got the greater than instead of the equal sign. Bray, what do you see?
There's a -3.
Okay, there's a -3, but you know what? There was a -3 in number 2. This needs to be a significant difference. Mason, what do you see?
Isn't 1/2 the slope?
Yeah, 1/2 is the slope. I agree. But look at numbers 1 and 2. Say the obvious stuff. Maybe this is so obvious that you're like, I don't want to say it.
There's an x and y.
There's an X and a Y. This is huge. Okay? Check this out. I'm going to give you some arm motions. Check it out. Please look at my arm motions. These are like carefully rehearsed. I spent 2 hours a day all summer rehearsing these. Okay? So they're really good. I'm kidding. Why would I ski it? You with me? Why would I ski that? Boring. I'd get X'd out. Right? There's both an X and a Y. I'll ski that. Make sense? Why would I ski it? It's horizontal. I'd get X'd out. That's vertical. If it's got an X and a Y, yeah, I'll give that a shot. I'll ski that. It's just a nice little slanted diagonal line. Okay? So you should be able to look at number 3 right away and say, you know what? It's got an X and it's got a Y. So I know for certain it's not horizontal. And I know for certain it's not vertical. It's going to be some happy diagonal angled line. Does that make sense?
Mm-hmm.
And all the other stuff you guys pointed out, pretty much true, right? The slope is going to be 1/2. It's got an inequality in it. We'll deal with that here in a second. All those other things are true. I just wanted you to get the big picture. Again, why would I ski it? I'd get X'd out. Oh, it must have an X and a Y because it's happily angled. Okay, so here we go. You guys pointed out some awesome stuff. Let's go there. You all said right away the slope is 1/2. I completely agree. Isn't this in that happy y equals mx plus b form?
Yes.
Slope intercept form? So I agree. Slope is 1/2. We should be able to tell the y-intercept, and you were kind of getting at that, Ellie, earlier. What would you say the y-intercept is?
-3.
I kind of disagree. It's about a question of form. The y-intercept is not -3.
0,
It's 0, -3. I don't think, I really do think that based on what we did earlier, I think it's really important for us to actually list out the point. 0, whatever. In this case, -3. Okay, so if we're going to graph this, Isa, what's the first thing I'm going to graph? Am I going to start counting off my slope first, or should I plot the point first, or something else entirely?
Plot the point.
We're going to plot the point. Okay, so 0, -3. Doc, what does that even mean?
Down 3.
Just down 3, agreed. Okay, so down 1, 2, 3. Looks like that. Trevor, what am I going to do with that slope of 1/2? How do I do anything with that?
I'm gonna go up 1 and then to the left 2.
So you said up 1, left 2. Oops, what do you guys think of that? No? Right 2? Right 2? So in a fraction like that, the 1 and the 2 are both positive. So I think it does mean up 1, right 2.
I saw the -3 in the slope.
Oh, okay. And that, of course, that is the negative is valid for the y-intercept, just doesn't affect the slope. Yeah. Okay, so there is a point there. And you could count your slope off backwards. If I was going to count the slope backwards, what would I actually do? What would you say, Sophia?
You would go down 1 and then 2 to the left.
Yeah, down 1, left 2. So down 1, left 2. And of course, you could just keep counting that slope off forever and ever. But we'll just settle for those. This is where this one gets a little bit different. I'm going to erase all my slope marks here just so I can do what I need to do. You don't really need to if you don't want to. I'm going to connect these with a lovely green line. Check this out. So let's see here. This line, oh, hang on. This line is going to go about like so. Y'all okay with that? What's the one thing that we have just completely and totally ignored up to this point? The inequality. We haven't even acknowledged that the inequality exists yet, have we? Just pretending like it's not there. We can't get away with that. So here's how we deal with this. It's going to be sort of like a little art project to finish up our class here. Where have you seen an inequality before? Yeah, do you remember those? We did like the number lines and we had like the open circle and the filled in circle. Didn't we do them then? Same inequality symbol. So if we were going to somehow try to graph this on a number line, would that inequality encourage us to do an open circle or a filled in circle? Open. So what does an open circle look like on a line? It definitely keeps going. I agree with you. But doesn't an open circle mean that we don't include that number? So how do we indicate that we are not actually going to include the line itself in our answer? Do you know?
I don't know if this is right, but isn't it like a break or something?
Kinda. Yeah, we might be thinking of the same thing. Well, I'm going to use a little different terminology, but you might be right.
Is it like a line segment?
No, it'll keep going. Sebastian's right about that. It will keep going. But you kind of might be right, too. What do you think, Mason?
Wouldn't it just stop at, I don't know, if it's greater than, would it stop and just keep going right?
It's going to, well, so it's like, is it going to go like, does it go like down here? Does it go over there, right? Or is it going to, you're thinking like the line is going to be forever long, right? The line is what it is. Oh, you were thinking chopping it off? Oh, okay. No, we're not going to chop it off. Almost like the segment idea. Maybe you guys have never seen this before. And if that's the case, I'm happy to teach you something. The way that you indicate that we don't actually include the line is you make the line a dotted or dashed line. So what I would do is I would go back in here with my eraser and I would just erase little chunks out of this line to indicate that it is a dotted line. That means that line is a boundary. It's a stopping or a starting point, but we won't actually include the line. It's sort of like an open circle. Okay, so this is going to be awesome. I'm going to come full circle back around to Bray's question. I hadn't planned on it going like this, but I'm going to. Don't the solutions, don't the parts of a graph, don't they have to make the original relationship true? Remember we talked about this, right? Whatever we have on the graph, whatever that graph looks like, it has to make the original relationship true. So I'm thinking, maybe I should test something out and see if it's really true. So watch this. If I just picked a point anywhere on the graph, maybe I try this one right here, 5, -5. If this point makes the original relationship true, this would be part of my answer. Can we do a quick, you know what, I'm sorry, let's just use an easier number. I'm going to say 4, -5. So about 4, -5. If I plug this in, watch what happens. The -5 goes in for y. The 4 goes in for the x. -5 is greater than 2 minus 3. Is -5 bigger than -1? No. -5 is further left on the number line, so -5 is not bigger than -1. Doesn't that mean that 4 -5 is not part of my answer set? Okay. So I'll just get rid of that. Maybe I should try a different point. Can anybody think of a really easy point for me to test out that like the numbers turn out numerically super easy?
0, 0.
0, 0 is always a great choice. Let's try that. So if I try 0, 0, I get 0 is greater than 1/2 times 0 minus 3. Isn't 1/2 times 0 to 0? Or what's 0 minus 3? So is 0 bigger than -3? It is. Isn't that weird? I tried out this point right here. I tried out 0, 0, and that's not even on the line, is it?
No.
So how could that make the original relationship true? It's because the original relationship is what sort of thing? Somebody say it louder, please. It's an inequality. So the fact that you've got an inequality means that there are going to be a lot of points that work. I'll give you some more examples. If I tried this point right here, it would work. If I tried that point right there, it would work just fine. In fact, if I tried any of the points up here, please don't pack up yet. All those points up there would work just fine. I could try all of them out if I had the time. I don't. You probably don't either. So here's all you have to do. Check this out. Would you guys agree with me that that line essentially took our graph and split it into two regions?
Yes.
So with an inequality, the answer is either going to be the upper left region or maybe the lower right region. And the way that you figure it out is you just test a point. And I prefer Doc's idea of 0, 0. If you can test out 0, 0, that one makes the most sense to me. And if that works, which it did, that means my region, my answer region, is up here where that test value works. So what you're going to do is you're actually going to be shading the region. So that graph right there, that would actually be my full graph. It would include the line dotted, right, or dashed, and it would include the shading indicating that all of those points up there would satisfy or fulfill my original relationship. Does that feel like something we should practice again? Good. We'll do that again. We'll do that again next time for sure. So thank you guys for your good attention. You're doing awesome. Have a good rest of your day. And don't forget, tomorrow would be a great day for a retry. Friday also would be a great day for a retry on a concept quiz. See you guys.